Please see the link in the description to download a worksheet for this video. If you've not already done so, we suggest that you watch the video on the rounding rainbow and the video on word form part 1 before you watch this video. When we study ecosystems, we learn that one of the major parts of an ecosystem are the decomposers, like these mushrooms. Mushrooms break down dead trees or plants into basic nutrients, which mushrooms use to grow. The word decompose means to break things down into their basic parts. In math, we use a similar word to decompose. That word is decomposition. It also means to break things down into their basic parts. In this video, we'll introduce a math idea called place value decomposition. We'll learn that each place value represents a specific size in a non-decimal number, and how to decompose a non-decimal number. First, let's learn that each place value represents a specific size in a non-decimal number. This metal object has a mass of 10 grams. For this video, we can think of mass as being like the object's weight, so we'll use the word weight from now on. This is a balance. For keep things simple for this video, we'll call it a scale. When we put the 10-gram object on the scale, the digital display shows 10. The little g stands for grams, just like the little g on the object. When we put 2 of the 10-gram objects on the scale, the total weight is 20 grams. When we put 3 of these 10-gram weights on the scale, the total weight is 30 grams. Please note that the number in the tens place value on the display is equal to the number of 10-gram weights on the scale. This applies if there are up to 9 10-gram objects on the scale. Please also note that each time we add one more 10-gram object, the tens place value goes up by one more. This metal object has a mass of 100 grams. When we put it on the scale, the display shows 100 grams. When we put 2 of these 100-gram objects on the scale, the total weight is 200 grams. When we put 3 of these 100-gram objects on the scale, the total weight is 300 grams. Please note that the number in the hundreds place value on the display is equal to the number of 100-gram weights on the scale. This applies if we have up to 9 of these 100-gram objects on the scale. Please also note that each time we add one more 100-gram object, the hundreds place value goes up by one more. This metal object has a mass of 1 gram. When we put it on the scale, the display shows 1 gram. Please note that the number in the ones place value on the display is equal to the number of 1-gram weights on the scale. This applies if we have up to 9 of these 1-gram objects on the scale. Please also note that each time we add one more 1-gram object, the ones place value goes up by one more. Next, let's see how to decompose a non-decimal number. We'll start by putting 2 of the 100-gram weights on the scale. Please note how the display's hundreds place value shows the number of 100-gram weights. Then, we'll add several of the 10-gram weights. Please note how the tens place value on the display shows the number of 10-gram weights. Now, we'll add the 1-gram weights. Please note how the ones place value on the display shows the number of 1-gram weights. This display shows a value of 255. Here's a quiz. Please write down how many of the 100-gram weights, 10-gram weights, and 1-gram weights are on the tray. We are hiding the tray right now, but can tell you that it is holding between 0 and 9 of the 100-gram weights, between 0 and 9 of the 10-gram weights, and between 0 and 9 of the 1-gram weights. Please note that the number in the hundreds place matches the number of 100-gram weights, that the number in the tens place matches the number of 10-gram weights, and that the number in the ones place matches the number of 1-gram weights. When we take a digital display like this and break that number down into its place value parts, we call this place value decomposition. We have just decomposed 352 into its place value parts. We found there are 3 hundreds, 5 tens, and 2 ones. Here's another quiz. Please decompose the number 264 into its place values. Let's do the experiment. The answer is 2 hundreds, 6 tens, and 4 ones. Sometimes we write the answer like this: 200 plus 60 plus 4. Thanks for your attention.